This is Precalculus Concept 35A. We're going to look at a new law called the law of cosines. And we talked a little bit about in class there are a couple circumstances where the law of sines just doesn't work, but there's another law of cosines, that works. And those particular cases are the side angle side scenario and the side scenario. So here's the law. If you have a triangle of any shape, any size, and you have A, B, and C, and the sides across little a, little b, and little c, the following formula holds. C squared equals A squared plus B squared minus 2AB cosine C. So kind of a lengthy formula, one you're going to need to memorize. And just a couple tips. I like to think about this being a version of the Pythagorean equation, where you have A, B, and C. And in a right triangle, of course, C squared equals A squared plus B squared. And that's exactly how this formula starts off. And that's a good way to kind of memorize it, is that it's really just the Pythagorean theorem. But then this term is basically an adjustment that needs to be made, because if you can kind of think about it, that is no longer a right angle, but rather something that's smaller. And so the side C would kind of shrink down, is a good way to think about it. So really you just kind of need to remember this term here. And that will take some practice. Take a minute right now though and write that formula down in your notes. Okay, I want to take a minute to just point out that formula can really be looked at from any angle in the triangle. So you might see some different versions of this in your book. For example, if I looked at side A instead, then it's really the same formula, but I'd have B squared and C squared instead. And in here I'd have 2BC, and then the cosine of angle A. What's really important is, regardless of what form your formula is in, that this angle and this side are always set up in that way. And you can see in my second formula here that side A and angle A are set up that way. Okay, and so you might imagine there's a third version of this, which would be B squared equals A squared plus C squared minus 2AC cosine, and then I would need to be sure to have angle B here. This may seem a little confusing, but a couple examples will actually indicate that this is not so bad. Remember to kind of start off as if you were doing the Pythagorean theorem, and then the minus 2AB cosine C is what you need to remember. Okay, here's an example. I want to solve for x. We're not going to solve the whole triangle, but rather just focus in on one thing. So I purposely didn't label this triangle, just to make you realize that it doesn't really matter. As long as I have an angle and a side across from it, I can jump right in with my formula. So here's how it's going to work. The length x squared is going to be equal to the length 4 squared plus the length 6 squared minus that adjustment factor that we talked about, which in this case is 2 times 4 times 6 times the cosine of the angle between the sides. Okay, that's a big long thing to work out. Do it on your calculator. Make sure you take the square root. That's a common mistake, but it turns out that x is about 7.8. Take a minute and actually do that on your calculator. Make sure you can get that answer to come out. Alright, here's a you try. Once again, you have side angle side to kind of start. Your job is to find x. This is very similar to the last example. If you need to, watch that again. But find the missing length x here. Alright, hopefully you set up your formula correctly. X is my unknown side, 70 is the side across from it, and 8 and 10 are my other two sides. You have the formula there. When you work it all out, you should get about 109.3. The common mistake is to say that that's your answer, but don't forget that's the square of your answer. So 10.5 was the correct answer. Alright, the other common time when you're going to use the law of cosines is when you start off with side, side, side. So side, side, side is the known quantity in this problem. And we're going to figure out angle R. I just picked that randomly, but I can figure out any of the three angles pretty quickly. Alright, so this time when I think about my side C, right, there's obviously not A, B, and C in this triangle, but I want to make sure it's the side that's across from the angle that I'm looking for. So that's going to be 6, right? So I'm going to start off with 6 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of R. And again, R, most importantly, is the angle that's across from side 6. Alright, this one's a little harder because I have some solving to do. Just like I suggested with the law of sines, the easiest thing is to kind of come up with one big thing that you have to solve, and then pull out your calculator. So 6 squared is 36. I'm going to subtract 5 squared, which is 25, and 7 squared, which is 49. And that's going to be equal to negative 2. Let's actually work that out. 2 times 5 is 10, times 7 is 70, right? 70 cosine R. And before I get my calculator out, I'm going to get the cosine of R all by itself. And so that's going to be 36 minus 25 minus 49. On my calculator, I want to put that in parentheses. And then I'm going to divide that whole thing by negative 70. Alright, now's the time to pull out your calculator. You're going to evaluate that expression. And cosine of R is going to be a decimal. And when I do the inverse cosine, I end up with angle R equals, and I think this ends up being 57.1 degrees. Okay, again, take your calculator out, make sure you get that as your answer. You've got a U-try coming up just like that, so you want to be able to make sure you can solve that. Okay, another example or another picture. Your job in this problem is to find angle A. See if you can set up an expression using law of cosines and solve it. Okay, again, the most important thing here is starting with the side across from the unknown angle or the angle that you're looking for. So 12 squared is going to be 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of angle A. Move stuff around and come up with something to type into your calculator. And remember, you'll need to do inverse cosine, and you should have gotten 125.7.